Hey everyone, this is our introduction to statistics. Before we introduce statistics, though, we have to learn some basic commands in R. All right, and this is important information. Why? Well, because we're going to use these commands pretty seamlessly within the problem solving we do in the next couple of weeks. So even though it is introductory information, don't disrespect this section. It will be important to us quite soon. And so what are we going to learn first in our first couple of notebooks after this one? We're going to learn about exploratory data analysis. We're given a data set, and then what do we do with that? And it turns out that the two basic questions we want to ask is, what kind of shape is the data? Are there any skew or outliers in the data? And to let you know about shape, the bell curve is a standard distribution that we see a lot in statistics. We have the uniform distribution, and again, a histogram or a density plot can show us the shape of that. Also, it can be skewed by outliers, so we're sometimes going to take a look at graphics like box plots, histograms, density plots, and learn about the shape and any abnormalities like skew or bimodal type data. All right. So we're going to learn about that just in the context of learning these R commands that we need. And as we go through the course, you'll learn how to pick out various characteristics and features within the data. All right. So we're going to start with a section on data frames. Why? Well, that's how R stores all of its data. And a data frame is a specialized table. It has rows and columns. Columns are variables and have a title. For instance, perfectionism might be a variable that we use in human subjects research, and then you'd have a column title, perfect, or what have you. And then each row is an individual from the research sample. Right. We're also going to learn about descriptive statistics. The main ones: mean, standard deviation, sample size. The 5-number summary includes the median, the min, the max, and also the quartiles, Q1 and Q3. Q1 is the 25th percentile and Q3 is the 75th percentile, and together they break up the data set into equally sized quarters. That's why they're called quartiles. And we're also going to look at some basic visualizations: histograms, box plots, density plots, QQ normal plots, scatter plots, these sorts of things. So we're going to have a section for each of those things. And as I said earlier, let's please take this seriously. This is information we will need. Okay, so the first thing is we've got to get these data frames loaded into R. We generally find data on the internet at a URL. And that's why R has this very cool function, read.csv. That's a comma delimited file. It's a specialized spreadsheet, Excel spreadsheet, honestly, in the way that it's stored a lot of places on the internet. And so this read.csv plans to take this comma delimited file and read it into R and then convert it to a table. So a special table called a data frame, so that it has all the properties and niceties and features that we like to use. Okay, and as I said, each row is going to represent an individual and each column represents a variable. And we've got a couple methods to do to what we call extract a column. Why would I want to extract a column? Well, let's say that this research collected 30 different variables. Well, we don't want to analyze all 30 at once necessarily. We can extract a column and just focus on perfectionism, or we can extract a different column and focus on optimism. So we do that. The $ method is we take the name of the table, right? So here the personality data set has been loaded. That data frame has been loaded as pers, P-E-R-S. We have a $, and then we have the name of the column, the column title that we want to extract. Okay. There is another method that we use, and the row column method. Okay, so So this does the exact same thing. All right, so let's jump back, right? The purse $sleep extracts a column, and again, we'll have a way to name that variable so I can pull that. This is a data vector now. Purse $sleep is a data vector, and we'll name it as some variable, maybe S or sleep, and we'll be able to work with it. And this does the exact same thing. So what's going on here? Okay, so the square brackets immediately enter us into row column mode. And this is very similar to linear algebra, where we identify elements within the matrix by specifying which row and which column it's in. And we do the same thing here. And notice, first of all, that the row space is blank. That's fine. When we leave the row blank, then it's going to take all the row values, which is good because we want the entire column. We're going to specify a column, but we want all the rows, all the values in that column. Okay, and then after the comma is the column, we're going to get that sleep column. And this also extracts the sleep column from the personality data set. Okay, so we've got these two methods. Quick review, right? We've got the $ method, purse $sleep, and we've got the row column method, purse, square brackets, space, comma, and then the column title that we want to extract. Okay. We can actually use the second method to create a subset of the data frame. In other words, this is going to create a 3-column subset of the larger data frame, purse. Okay, and what are we doing? Well, we're using the concatenate function. And the concatenate function, what does concatenate mean? Concatenate basically just means to join together. And a concatenate function, they're used all the time in computer science, these computer programming languages, and it's exactly to do exactly what it sounds like, to join things together. And different ones have different features. This one just takes the column sleep and the column caffeine and the column age. And so there's 3 column titles, and what it's going to do is going to grab those 3 columns, and since the row was left blank, it's going to grab all the rows, and it's going to create a new data frame that just has these 3 columns of information. So just 1 second before we jump in and show how to do this in the notebook, there is another command or two. It turns out that often when we load a data frame, we don't even know how many columns or rows are in it. And just as an initial getting some sense of the size and scope of the data, we often use ncol and nrow and the data frame name to find these things out. So let's jump in to the data frame section of the notebook. So here we are, and you can see that the very first thing we do is we use the read.csv command, and you should become familiar with this. Why? Well, because all the data for the course is stored on my faculty website, and sorry I drew that underlined so that it covered up a lot of the text you need to read, but this URL, https:// right, all of that at faculty.ung.edu.rsyn, that's my name, /data. And then we have a bunch of different different data sets. This one is the personality.csv. Okay, so we import that and set it to the name PERS, purse. So purse is just a variable location, just a name. And then we put this data frame in it, right? The read.csv loads the data, configures it into a data frame, and so purse is the variable name that we'll use to refer to it. And the head command is like a summary command for the table or the vector that we're looking at, and it shows the first few entries. And since we said (5), it's going to show us the first 5 rows of the personality data set that we just loaded. Okay, so that's already done for us. And then they're saying, hey, using the $ method, extract the age variable or the caffeine variable or the sleep variable. And okay, so let's do it. We have to replace these ellipses. All right, so age, what I'm gonna do purse $age. Okay, and the same thing. They want me to do it for all three, so Perth $calf. Notice that I'm capitalizing age and calf and sleep. If you look back at the titles, the first letter is capitalized. So that may not have been obvious in the quick look that we had, but this will do it. Okay. And you may be curious, well, how do we know that it did it? So let's just open up another code block, right? And so I can say S, show me the sleep variable. And hang on just a second. Oh, this is Markdown. Let me switch to code, sorry. And so when I do the code, and it says the person not found. All right, so let's go back to the top and load the data frame again, right? And now the sleep variable is displayed, and we can see the average hours of sleep per night, right? If we do age, we'll see a bunch of college students' ages, and those all make sense. And then caffeine, these are the number of 8-ounce servings of caffeine per day. And you see a lot of students with 0s and 1s, and then you see some students with 6s and 8s that are drinking a lot more caffeine. Okay, so this is the $ method for extracting a column, and then we have a data vector. And we can do things with that data vector, which you'll see in just a moment. Then the row column method, they say, okay, let's get some practice on the row column method. Okay, so the row column method requires me to use square brackets, and the row we're going to leave blank, and the column we're just going to put the name of the column in quotation marks. Okay, and we're going to do this again for calf and do it again for sleep. Let me emphasize the single quotes versus double quotes. It doesn't matter which we use in most cases, as long as I use the same opening and closing quotes. It will work, okay? And again, you'll see me opening up another command block here. Why? Well, I'm just going to make sure that age is displaying properly, and you can see that it is, along with S. Okay. So the two methods we have, the $ method we showed up here, and the row column method that we showed here. All right. And remember that the row column method can be used, and we can grab more than one column. Okay, so that will be useful at times. And then the number of rows and number of columns, right? I can just type and call pers, which is the name of my data frame. And there are 36 columns, and I can do n row for the personality data set. Oh, n row, not now. And so we had 129 individual students that filled out these surveys, and in the personality survey data set. And there were 36 different variables. Now, some of them are demographic variables like age and, core, yes or no, resident or commuter student. There are demographic variables that we have. And then we have a lot of other variables. The undergraduate research that the data pertained to was studying humor styles. So we had a lot of other personality variables because our sense of humor is connected to other things about our personality. So that's where the data set came from in the 2012 era. And I don't know, we did collect data over 2 to 3 years for that project from our statistics courses. And which year it was, 2011, 2012, 2013, that's the correct era. All right, so let's look at the descriptive statistics. We'll jump back here. All right, and descriptive statistics just describe a data set, and you're familiar with many of these terms: the mean, the standard deviation, the sample size. Those are the standard descriptives. The five-number summary. The five-number summary includes the median, the max, the min, and the quartiles, Q1 and Q3. So Q1 is the 25th percentile, and Q3 is the 75th percentile. So the five-number summary breaks the data set up into equally sized quarters. All right. And while we're going through the descriptive statistics, we'll find that the cat function is really helpful. The cat function combines the features of the print function and the concatenate function. So what I can do is I can put commands together with text. So that'll help me format the output in a way that's much more readable. Okay. So let's jump back into our notebook here, and descriptive statistics. Well, if you recall sleep, we already created this variable s, and we want to create the mean, right, and the standard deviation, and the sample size is just the length of that data vector, right? Whatever the number of entries in that data vector is, that's our sample size. And if I run this, you can see that the average number of sleep hours was 6.24, and the standard deviation is 2.13, and there again were 129 students. Okay, and this isn't horrible. Five-number summary, I just type summary of that data vector S, and notice that I get the min, the first quartile, the median, the third quartile. It's also displaying the mean in there. The mean is not technically part of the five-number summary, but it is helpful to compare the mean and the median. Why? Well, because if there's outliers, if the outliers are extreme enough to cause some skew in my data, then the mean and the median, the difference in the mean and the median will let me know that perhaps that's an issue. Okay, it can signal that's perhaps an issue. So what are we going to do? We're going to take the cat function, okay, and we're going to type in some text. So here, let me move this higher in the screen just so it's easier to see. Okay, so the standard descriptives for sleep. And then what I'm going to do, I'm going to put a little space, comma, mean, wait, sorry. I'm going to do mean equals, right? And then a space, and then I'm going to do the mean of S, and I'm just going to let you see that for a second. Right, so now it's printing out. One thing that really helps us in the formatting of these is the hard return, okay? So let me show you that. I'm going to use the /n, and I'm going to put a couple spaces. Why? That's going to help with an indent, right? So now I have the mean. And by the way, I will make the point that I can put an enter and a tabs in there. And now this won't affect the command. The command will still do the same thing. Okay. And I can continue to add in, for example, let's see, /n. Sorry, I need quotes here, right? /n, 1, 2, 3, and I'm going to do, I'm going to abbreviate standard deviation equals, right, and it is SDS, and we're doing pretty well here. I'm going to pause for a moment and see, okay, so mean, standard deviation. By the way, we can round these. Right, so I can say round the mean for the sleep hours to 1 decimal place, and I can round the standard deviation to 2 decimal places. This can all happen inside the cat function. Okay, and I'm not quite done, right? I still have some standard descriptives, so I might want to do / excuse me, /n, 1, 2, 3. We're also going to do sample size equals, comma, length of S, right? And yeah, so this is how we work with the cat function. I'm going to do one final thing. I am going to add in the 5-number summary. Now, I'll explain initially that the text is only going to describe what is happening, the 5-number summary for sleep. Sorry. Okay, and then what am I going to do? I'm going to do summary outside the cat statement. Why? Well, oh, it doesn't like it. What did I not do correctly? I did not put a comma, right? So all the things that are, all the different elements in the cat statement, they're separated by commas, and I failed to do that. And there, everything prints out nicely, standard descriptives, and the 5-number summary. What happens if I include the summary in this command is that the formatting of the summary command goes away, right? The cat function overrides the nice layout and formatting that the summary command will do. That's why I just put this text here. Sorry, I was trying to this text here, and then close the cat statement. Right, close the cat statement and then do summary S, and then, sorry. Something has happened here, and I'm not quite sure what I did. Oh, no. Let's go back down to the cat function here and see what is happening. Oh, it doesn't need a comma. That's what's freaking it out. Okay, sorry. As I reconfigured that cat statement. All right, and now when I put the summary statement outside the cat statement, it retains this nice formatting, and it has the title row above the values so we can see what those values are. Okay, so that's what I meant about the cat function, allows us to do some formatting. So especially with the descriptive statistics, the cat function is very helpful. Finally, let's take a look at data visualization. And these are things like histograms and box plots and scatter plots that you guys have seen. But we also have some diagnostic graphics, the normal QQ plot. The stem plot is a nice hybrid that we use. And the mosaic plot is a plot that you may not have seen, but helps us analyze categorical data. All right, and we have some standard graphical parameters. We have titles for the main title, for the x-axis, the y-axis. We can change the color of the lines that are drawn. We can change the line width. So we can make a line a little bolder so that it's easier to see. We can change its color. What's nice is R standardizes a lot of the graphics options. Now, not every plot has every option, but if it does have that option, it's going to be named the same thing and called the same way. All right, and our course notes have a page with these options described and demonstrated. And that's back in the appendix. So if you scroll down on the left in our book and get to the appendix, the helpful tools section has a section for graphical options. And so if you need to be reminded, that stuff is there. And let's jump back in, because I believe they say, hey, we're going to demonstrate how to do these. And what are we going to do? Well, we have our sleep variable, so let's just just hist s, bam. And it shows us a histogram. Okay. And again, some of those options, I can do the title and say histogram colon sleep variable, and I have to put that in quotes. Again, either single quotes or double quotes will work. Cha-ching. And I can add X label, Y label. I can change colors. Um, let's call equals blue, for example. And now, okay, my histogram has turned blue. That's perhaps not visually appealing to you, but you can try a different color that you need, or we can not do a color at all. So I don't want to teach all of the options, but I just wanted to throw a few out there. They are not that hard to remember and to use. Okay. And scrolling up just a little bit. Why? Because they say, oh, box plot. What is a box plot going to look like? Well, let's do it for the sleep variable. Cha-ching. And this is nice. They do a vertical box plot, which is fine. I like those. We do have this option with box plots. Horizontal equals true. Sorry, true. Oh, and I must not have that right because it's going to show its vertical box plot. The nice thing about the box plot is it shows the 5-number summary, but it also identifies outliers. We will talk about that in the next section. This has 2 outliers to the left or below the main group of data. Notice that the rectangle in the box plot shows the middle 50%. Why? Well, the top of that rectangle is at the 75th percentile, and the bottom of that rectangle is at the 25th percentile. So it draws a box. The box plot draws a box from Q1 to Q3. So it draws a rectangle, and that shaded rectangle is around the middle 50% of this data. Okay, and we'll talk more. What else? Well, let's try this stem plot and see what that is. Sorry, I did type stem. Stem S. And what does it do? Okay, so it shows a display, somewhat like a histogram, but it has all the data included, okay? And so, how do I read this? Well, it says the decimal point is here, so I know that these values are 4.0s and 4.5s. Okay, so this is nice because if I turn my head sideways to the right, I get a histogram look. I see the shape. Also, I see the extended tails that may show skew and outliers. All right, and I can also read the data off the table, and I can see, oh, wow, the longest bar here is the people that are getting 7 to 7.5 hours of sleep at night. Okay, so the stem plot is very good, and it has this scale option. What does it do? As I increase the scale, I get more bars, so it'll split the stems. So we have both the 2.0s and the 2.5s. It's easier to see on the 3 line. We have 3.0 hours of sleep and 3.5 hours of sleep, and they're split, right? That is not particularly pleasant. It didn't help the visuals. One is the normal. We can try things like 0.5. The decimal places don't usually add much. I'm not sure that it recognizes anything other than integers. But this particular stem plot was showing fine with a scale of 1. That's the default. Okay, so we have 3 of them accomplished so far. The scatter plot. And let's see what we have loaded. Oh, we have caffeine and sleep. So let's see if there's a correlation between caffeine and sleep. And let's just make sure that the caffeine variable is working and the sleep variable. Okay, so just printing them out to make sure everything's good. And what do? Well, I just do plot, and I'm going to say plot calf. Wait, I don't need the quotes, I don't believe. Okay, plot calf and S. Sorry, S. I'm going to do this data equals pers. This is often an option just to let or no, you say, hey, here's the data frame that I'm using, and go find these titles. Oh, and if we're using the titles from the data frame, I should be able to do this. And it didn't like it. Okay, that's fine. I can do it this way. I can just say purse $calf and purse $sleep. So I can use these, extracting a column in the middle. Okay. And now I have a scatter plot. If I give it two numeric data vectors, it creates a scatter plot. And notice that the first one that I entered, the purse $calf, is my x-axis, right? So the first one entered goes along the x, the second one entered goes along the y-axis. Okay, is there a way to superimpose the line of best fit? Those of you who have seen some basic statistics before will be used to the line of best fit being superimposed. And yes, we will learn to do that. That's a little more difficult because we have to use the linear models function first, and then we can create a line of best fit. So that's I don't want to cover that right this second, but just the basic scatter plot is just plot and then the names of the two variables. Okay, I'm trying to remember. We've done, and a density plot. If we're looking at a density plot of the sleep variable, let's just plot density S, and here we go. And I will, again, I'm going to create a main title, main equals, quotation marks, density plot, colon, sleep hours. And I misspelled main. Mean I wrote instead of main. And it threw that error. Okay, but here we go with a nice density plot. And the reason I chose this example is because this is why we prefer a density plot sometimes to a histogram. Why? Well, I see this feature in the graphic, and I see a slightly extended tail to the left in the graphic. Now, up here, what are we seeing? Well, when we have two values that the data set clusters around, right? We have two modes, right? So generally speaking, the tall areas in the graph, right? That's the mode, the most commonly used data points. But here it turns out that we're having a second mode emerge. Now, is it truly bimodal data? No, it's just a little hiccup there. But there's a second value around which some values are clustering. So it lets us know when there are these little nuances in the data set. Okay, so that's a density plot. We love density plots. Okay, and I think we have one more. Oh, a mosaic plot. And let's see what variables we have. Let me pause the video and get back to you with a proper example. All right, so we're going to do a mosaic plot. And the reason I needed to pause was because mosaic plots help us analyze categorical data. So I had to think about the data set and which categorical variables we wanted to use. Okay, so well, here's the whole function that we have. The name of the plot is mosaic plot. And what am I doing? The first variable I'm putting in is accept date. Then I'm using the tilde key. That's above the tab key. Accept date. And then I'm using the biological sex variable. So accept the date question. How did that go? The accept the date question was this. At a time in your life when you're not romantically involved with anyone, someone asks you out. You feel that this person has a wonderful personality, but you do not find this person physically attractive. Do you accept the date? Yes or no? And the question now is going to be, well, are the yes-no responses to the date question going to vary based upon the biological sex of the person who is answering? I'll throw this in, this data equals purse. Again, this is saying, hey, accept date and sex. These are columns in this data frame, PERS. And so there it works. Again, I tried this on another function. Why? Well, because it's one of those things that often works. Okay, and if you'll notice that except date tilde sex, I'm creating a statistical formula. Now, there's a whole help page on statistical formulas. Um, and again, that's in the appendix, like the graphical options help. Um, and just like we have equations in certain formats in algebra, like y equals mx plus b. Well, the m is the slope and the b is the y-intercept. And we know what these things mean. As we go deeper and deeper into algebra, we have more and more kinds of equations. Um, we have standard equations for all of our conic sections, so in the same way, statistics has some. And what does this say? This formula is saying, hey, except date is a category variable and sex is a category variable, and I'm going to split out and look at the breakdown. Well, we see for the females, which are in the top of this graphic, right? Here's the rectangle that represents the nose, and here's the rectangle that represents the yeses. You can see that for females, the yes option is much more popular. What about for the males? Well, for the males, the bigger of the two rectangles, they're about equal in area, slightly different shape, but clearly more no's from the males than yeses. So is there a difference? Well, I don't know, but we can visually see, yes, there appear to be some differences. Exactly what those are, we would have to do some statistical testing to find out. All right, so mosaic plots are really useful for these category variables. And that's it. That's a quick overview of the kinds of commands that we're going to use to do these basic statistical tasks in our course.